your time, chasing stars. You live in the moment, carried away from who you are.
Good morning. Morning. Yo, what's up, everybody? Excuse me. Hope everyone had a good weekend. Went camping and fun. It was so hot, even though it was only like 80s. It was just beaten down, high UVs. But it was fun. It was kind of a bit more north. Went to this place called Ice House Reservoir. And it was still much cooler than it was in kind of the city here. So, yeah, it was a fun time. But we're back at it. Today we are, we're just going to watch Elon Musk's talk that I was supposed to watch the other day on stream, but he postponed it twice. So we're gonna watch his The Road to Making Life Multiplanetary, SpaceX's plan to reach Mars. It's 42 minutes, so we'll watch this, and then I have a few other smaller topics that we'll take a look at if we have time, and I have a few other space videos that we'll watch here too. So yeah, let's just jump into Elon Musk. Old Musk boy. Now that he's now that he's not working at Doge, he could put, he's actually back at being more of an CEO engineer type. So hopefully the hopefully he could focus on this stuff and not the other dumb shit he's doing. So let's watch this and we'll see what he's gonna say. The only thing I will say before we watch this is we watched the other day when this was supposed to happen, we watched some of his highlights from the previous one that he gave, I think in September around 2016. And he wanted to, by 2022, there was supposed to be not only humans on Mars, but multiple starships already should have been to Mars by now. So we're a little behind, but again, that's Elon Musk. You're supposed to also have cyber taxis taking everyone everywhere. So yeah. So I guess I'm curious to see now what the actual updated timeline is and how achievable it is. So it also sucks that it's on X. And here we go. It's literally just auto pausing. Bro, the video player on X is so dog shit. Views make no sense. Like, all right. Can actually upgrade the quality. Okay, there we go. Like we're good. And then turn the volume up a bit. Alright, should be good. And yeah. Actually, these are cool shots. I did see a spoiler for this. I guess if there's spoilers, if that counts.
Flight directors go for launch.
These are really cool shots, though.
Stage separation. Booster landing burn startup. Starship is transforming.
It sucks they had I mean, I know they collected data, but it sucks that the last launch wasn't didn't go exactly as planned.
There you go.
Full
All right.
SpaceX is make
The gateway to
technologies necessary
Mars.
for life multiplayer.
So here we are. Here we are at the newly incorporated Starbase, Texas.
I wonder if this is pre-recorded or if this was live when it
This
came
is
out.
the first new city made in America in, I think, quite a few decades. At least that's what I'm told. And very cool name. And it's named that because it is where we're going to develop the technology necessary to take humanity and civilization and life as we know it to another planet for the first time in the 4.5 billion year history of Earth.
All right. Okay, like one thing, I know I'm already pausing. I'm surprised. Like, it is weird that he is kind of just ignoring the moon. It's like he's like, the government's got the moon. Like, I'll just take Mars. But I feel like it would be valuable to like figure out the moon first. Oh, considering that SpaceX is a part of NASA's like moon plan. Maybe we'll talk about it.
So go with this little video here. This is how it started off, with basically nothing. So Starbase started off as basically a sandbar with nothing. Even those little things we built, obviously.
It is
That's the
interesting.
original sort of Mad Max rocket.
Like, it is crazy to see where you start and kind of where you begin, especially like when there's a lot of physical space, because you could really see the change.
This is where you discover lighting is very important for that Mad Max rocket.
The, like, ambiance in the background too is kind of like peaceful.
So yeah, not that
relaxing.
long ago, there was basically nothing here. And in the space of about 5 or 6 years, thanks to the incredible work of the SpaceX team, we've built a small city. And we've built 2 gigantic launch pads and a gigantic rocket factory for a gigantic rocket. And the cool thing is, for anyone out there who's watching this, you can actually come and visit because our entire production facility and launch site are on a public highway. So anyone who comes to South Texas can come and see the rocket pretty close up and see the factory. And so if anyone is interested in seeing the largest flying object on Earth can come here anytime they want and just drive down the public highway and see it.
That seems like
pretty cool.
I guess like it's a public highway, but it seems like a logistic pain in the ass having like
where we are
random
now.
ass tourists come all the time.
Starbase 2025.
It is kind of crazy, like it
So
is like the
we're now at the
progression.
point where we can produce a ship
Very
roughly
science
every
fiction-esque.
2 or 3 weeks. Now, we don't always produce the ship every 2 or 3 weeks because we are making design upgrades. But ultimately, we're aiming for the ability to produce 1,000 ships a year, so 3 ships a day.
3 ships a day.
So that's where things are now. I'm standing in that building.
In 1,000 ships was the original estimate from like his 2016 one. It was like 1,000 ships. Like, it kind of broke it down, but I can't remember. So that still seems to be the goal.
That's our hovercraft.
The thing is sick. Okay, I don't want to look at you.
We're driving a booster
Cool shot in the reflection.
down the road to the launch site.
It's crazy though. Like I feel like, bro, like one day it's just gonna like break off and like float into the water. Like, it is crazy, like that they are on like this like
You can see the mega
sandbar
bays.
esque type of area. Great for shots and views like this, but Nah, I mean it's a engineering company. They do.
And as I said, what's cool, the cool thing for those out there watching this video is that you can actually just
their judgment on this, I guess, is what I'm saying.
you can see the mega bays. And as I said, what's cool, the cool thing for those out there watching this video is that you can actually just literally come here, drive down the road and see it, which is the first time in history that that's been possible. So all this cool stuff, that road on the left there, that highway is public, and you can just come here and see it, which I recommend doing. I think it's very inspiring to see. So that's our Gigabay. So we're expanding integration to produce 1,000 Starships per year. Well, yeah, that hasn't been built yet, but we're building it. That is a truly enormous structure. This will be that'll be one of the biggest structures, I think by some measures, the biggest structure in the world. And it's designed for 1,000 Starships a year. We're also building a Gigabay in Florida, so we'll have 2 facilities, one in Texas and one in Florida. It's actually difficult to gauge the size of these buildings because you need a kind of human for scale. When you see how tiny a human is next to that building, you realize just how enormous it is. So when we look at our build comparison, vehicles per year, so you look at Boeing and Airbus making airplanes, Starship will be making, at some point, probably as many Starships for Mars as Boeing and Airbus make commercial airplanes. So this is really at a scale, enormous scale. And each Starship will have a capability, each Starship is bigger than a 747 or an A380. Like, it's truly enormous.
Yeah, and I swear, like, last time around, he talked about using Starship as just a planetary transport vehicle, like, just using it to, like, fly. You could go up and then into space and then go over to, like, you know, China or, you know, somewhere. It's, like, somewhere far on the other side of the planet. It'd be really efficient of actually transporting large sums of cargo like that. I think this is kind of, like, you know, could help with that. 1,000 Starships, though, is insane. Like 1,000, especially if they're reusing boosters. Like, it's so many.
And then in terms of
for such a large structure,
Starlink satellites, the version 3 satellites, making on the order of 5,000 a year.
Like, can we make like how are you making the fuel?
10,000 a year.
We gotta talk about the fuel production. Or something.
Starlink V3 satellites are each the size of roughly a 737. They're pretty big. That compares to the B-24 bomber in World War II.
Wow.
Now, it's still small compared to Tesla. And Tesla will probably be doing, you know, double or triple that volume in the future. So it just puts things into perspective that it is actually
Wait, what is this Tesla number? I don't get that.
A vast number of interplanetary starships. And even when you can compare things on the
Tesla's not building 1.7 million vehicles per year.
tonnage standpoint, Tesla is still, and other car companies are still building far more complex manufactured tonnage than SpaceX, which just really is a way of saying that it's very achievable. Like these numbers, while they are insanely high by traditional space standards, are achievable by humans because they have been achieved in other industries. Progress is measured by the timeline.
Holy shit, wait, Tesla does make, correction, they make way more cars than I thought. Bro, this website is dog shit. Yeah, wow. That's crazy, actually. Genuinely. I didn't believe that.
Establishing a self-sustaining civilization on Mars. That's how we're gauging our progress here at Starbase. So with each launch, especially in the early days of Starship, each launch is about learning more and more about what's needed to make life multiplanetary and to improve Starship to the point where it can be taking ultimately hundreds of thousands, if not millions of people to Mars. Ideally, we can take anyone who wants to go to Mars, we can take to Mars. And bring with it, bring all of the equipment necessary to make Mars self-sustaining, so Mars can grow by itself in a worst-case scenario, getting to the point where the fundamental fork in the road for human destiny is where Mars can continue to grow even if the supply ships from Earth stop coming for any reason. Mm-hmm. At that point, we've achieved civilizational resilience, where Mars can potentially come to the rescue of Earth if something goes wrong, or maybe Earth could come to the rescue of Mars. But having two planets that are both self-sustaining and strong, I think is going to be incredibly important for the long-term survival of civilization.
That's so interesting to think about. Also, it poses the risk of, I'm thinking of like The Expanse or something. Like, if Mars becomes self-sustaining, who says that they even want to be associated with Earth then? You know, they're like, we're our own government, like, fuck off. You know? Granted, they would have probably very little bargaining power, because Earth would be like, okay, you're never getting another shipment again. Also, I think that I still am curious who genuinely wants to go to Mars. Like, initially, it's essentially going to be a labor colony, you know, not by design, but just by the fact that it's just hard. It's going to be hard work. Like, the life lived there is hard. You know, like, I think, you know, a good example would just be looking at how astronauts initially lived on the moon, how astronauts currently live on the ISS. You know, it may seem really cool, but like, it is hard. It's very, you know, hard on your body, the mental, you know, toughness, I think, is probably the biggest one, because like, they aren't, you know, sleeping too well. Like, there's other, you know, you're away from people and, you know, society. Like, you know, there's just like other things like that is like very hard. And I feel like it poses so much risk too. So I think, like, you know, sure, yeah, someone could even go to Mars, but like, one, why would they want to go there? And two, I just feel like it's gonna be hard to even like police society in a way, if you want to say that. Just for the fact of like, one person goes crazy and that like could just take out the entire colony, you know? It's like, I don't know, how do you contend with those things? And I mean, assuming then that to me, that makes it seem like military would be the first use case there, because they're, you know, regimented, will listen and everything. But also, who's to say that, like, why wouldn't some other country want to come and like sabotage it? I know I'm talking about like all the negatives, but like, I don't know. Those are all the reasons why I would not want to go, maybe. Besides just basic survival.
So, like, just I think any given civilization is likely to last maybe, I don't know, 10 times longer, maybe much longer, if it is a multi-planet civilization than if it is a single-planet civilization. Because there's always some chance that, you know, us humans could do something crazy like World War III. Hopefully not, but it's possible. Or that there could be some natural event like meteors or supervolcanoes or something that we don't expect. And,
yeah, that volcano in Italy.
If we only have one planet, then that could be curtains. But if we've got two planets, we keep going, and then we go beyond Mars, ultimately, to the moon, maybe the asteroid belt, the moons of Jupiter, and beyond, and ultimately to other star systems. And we can be out there among the stars, making science fiction no longer fiction. So in order to achieve this goal, we have to make rapidly reusable rockets, so that the cost per flight, the cost per ton to Mars, is as low as possible. That's essential. So for that, rapidly reusable rockets, I said, it's actually 4 R's. It's like a pirate. RRR. It's like rapidly reusable, reliable rockets is the key. RRR. Now we've congrats to the SpaceX team on making incredible progress on catching
Cool
a
views.
giant rocket. So it's really mind-blowing that the SpaceX team has been able to catch the largest flying object ever made multiple times, using a very novel method of catching it out of the air with giant chopsticks.
Not seen that view. That's cool.
I mean, have you ever seen that before?
The guy raises his hand. These are great shots. I wonder if it actually like bounces off the rocket. Like it like pinches the rocket at all. It looks like it does.
Yeah, congrats again. That was an incredible achievement. So the reason we are catching it in this way, which is never been done before, is in order to achieve the rapidly reusable portion of the, in order to make the rocket rapidly reusable. So if it is, if the super heavy booster, which is gigantic, it's like 30 feet in diameter. If it were to land with landing legs on a landing pad, we would then have to pick it up, stow the legs, and put it back in the launch pad. And that's it's quite difficult to transport such a large thing. But if we catch it with the same tower that it's used to put it in the launch mount to begin with, that is the best case outcome for rapid reuse. So it literally gets caught by the same arms that placed it in the launch ring, and then it is placed back in the launch ring immediately. So in principle, the Super Heavy booster can be reflown within an hour of landing. So it comes back in about 5 or 6 minutes.
It's like, how? Okay, how?
And then it gets caught by the tower arms, placed back in the launch mount, and then you can refill propellant in about 30 to 40 minutes, and place a ship on top of it, and in principle, refly the entire booster
inspection
every hour.
I ain't flying on a reused rocket if no one inspected it, bro. I need to be checked for safety.
Extra time.
Tell you that much.
But let's just say it's in the limit of rapid reuse. And then the next thing we need to do is catch the ship too.
Yeah.
So we haven't done this yet, but we will.
So this is, it looks like an animation. So they're catching it the exact same way.
So that's what we hope to demonstrate later this year, maybe as soon as 2 or 3 months from now.
Wow.
And then the ship would be placed on top of the booster, and then again refilled with propellant and flown again. With the ship, it takes a bit longer because it's got to orbit Earth a few times until the ground track comes back over the launch pad. But the ship is also intended to be reflown multiple times per day. This is the new Raptor 3, which is an awesome engine. Big hand to the Raptor team for this. This is very exciting.
Dude, what was the stat? Each Raptor 3 saves more than...
So Raptor 3 is designed to require no base heat shield. saving a lot of mass on the bottom and actually improving reliability so that if there is, for example, a small fuel leak from the Raptor engine, it will simply leak into the existing flaming plasma and not really matter. Whereas a fuel leak when the engines are contained in a box is a very scary thing indeed. So this is a Raptor 3. It'll take it probably a few kicks at the can, but it is a massive increase in payload capability, in engine efficiency, and in reliability. So this is really a revolutionary engine. Raptor 3 is really, I'd say, kind of alien technology rocket engine. I mean, even industry experts, when we showed a picture of the Raptor 3, said that engine is not complete. So then we said, well, here's the engine not complete, firing at a level of efficiency that has never been achieved before. So
it looks so clean. It is kind of crazy, like how there's like so little.
I mean, that is one clean engine.
Yeah. Okay, he's very lackluster on details, I guess, so far. Like,
so in order to make the engine
like it's nothing
like
we haven't known. We don't know yet.
Simplify so many parts of the design, incorporate secondary fluid circuits and electronics in the structure of the engine itself. So everything is contained and protected. It is a marvel of engineering, frankly. Then one of the other technologies that's key for Mars is doing
in-flight refueling. Like, this is a huge key that they have not talked about at all yet. And last time around, this, like the last talk he gave in 2016 was, he talked quite a bit. There's like a bit about this, but also this is just a requirement for going to Mars. And there's been like zero progress on it. And I think this is probably one of the hardest parts, is the fact that we are going to have to do like this refueling in orbit. I feel like it's not necessarily that it's hard. It's more so that like it's probably just like when dealing with like gases like this especially in like a vacuum, new, it's something that hasn't really been done exactly. So
orbital propellant transfer. So you can think of this like similar to aerial refueling for airplanes, but in this case it's orbital refilling of rockets, which has never been done before. But it is, technically feasible. I always feel like these things are a little NSFW, sort of. Listen, you got to transfer fluid somehow. This has got to be done. So the two starships would get together, and one starship would transfer fuel and oxygen. And actually, most of the mass is oxygen. It's almost 80% oxygen that gets transferred, a little over 20% fuel. And so once you send a starship to orbit with that's full of payload, and then you send a bunch of other starships up, and you would refill the propellant on that starship. And once the propellant tanks are mostly full, then you can depart for Mars or the Moon, or yeah. So this is an important technology which we should hopefully demonstrate next year.
Wow! All right.
Yeah. So then with one of the toughest problems to solve is the reusable heat shield. So no one has ever developed a truly reusable orbital heat shield. So it's extremely difficult to do so. Even the shuttle's heat shield required several months of refurbishment, basically fixing broken tiles, testing each tile, and because it's an extremely hard problem to be able to withstand the extreme heat and pressure of reentry. And the only things that can really withstand this level of heat are advanced sort of ceramics, kind of basically glass, alumina, some types of carbon, but very, very little actually can survive and with reusability without eroding or falling off or cracking.
Because yeah, theoretically, if they fly a starship to Mars, it would have to descend into onto Mars through the atmosphere. So the heat shield would then have to be used then, and then it would likely have to take off and then come back to Earth and also go through Earth's atmosphere, deflecting the heat then with the heat shield. So it'd have to be at least used twice in that sense. I wonder if even just that would be a lot. The fact that it's a fully reusable, I don't know,
can survive the stresses of re-entry.
You need some sort of thing that molds under heat and then goes back or something, under cooler temperatures or something. Some sort of good reformat.
So this will be the first time
reform
that it's done, that a reusable orbital heat shield is developed, and it needs to be obviously extremely reliable. So this will be something that we'll be working on for a few years, I think, to keep honing the heat shield. It is an achievable thing, so we're not trying to do something that isn't achievable. It is within the realm of physics to get this done, just an extraordinarily difficult thing to get done. And Mars, the Mars atmosphere is carbon dioxide, which at first may seem better, but actually it ends up being worse because when the CO2 turns into a plasma and you actually end up with more free oxygen entering on a Mars atmosphere than on Earth atmosphere. So Earth's atmosphere is only around 20% oxygen, and Mars ends up being basically more than double that, maybe triple that, when you consider when the CO2 becomes a plasma, and you get carbon and O2. So that wants to oxidize the heat shield, basically burn the heat shield. So that's why we tested very rigorously in a CO2 atmosphere, because it's got to work not just for Earth but also for Mars. And we want to use the same heat shield for Earth that we use for Mars, because there are many other factors with the heat shield, such as making sure the tiles don't crack or fall off or anything like that. So we want to have the same heat shield structure, same material on Earth as on Mars, so we can test it hundreds of times on Earth before going to Mars, and be confident that when it goes to Mars, it will work.
Oh wait, so did they get rid of the wait, is this new? I swear that they didn't have this flame diverter for the engines or whatever. That's why the whole they have the water there now, the concrete, because the concrete pad which is getting torn up. I'm also pretty sure the future starships are going to be bigger.
Developing some next generation starships, which have a number of improvements versus our current gen. So it's taller, for example, and has
looks like a different launch pad.
The interstage between the ship and the booster. You can see that sort of the sort of struts there. That makes it easier for the flame. Like that right there. When doing hot staging, which is when we light the ship's engines while the booster's engines are still firing, the flame from the
it's also crazy that this thing is that tiny ass thing on the picture, but look how fucking big just this tiny section is.
Through the open struts of the new interstage, and in this case, we'll bring the struts interstage back with us instead of throwing it away.
Yeah, because it's like a ring that kind of they discarded before.
A little more height here, 72 meters from around 69. Propellant capacity, I think we'll probably push that up a little, maybe 3,700 tons.
So is there only little 3 little wings here?
Long term, my guess is we're maybe around 4,000 tons.
Interesting.
And but just sort of just over 8, sort of 8,000. Probably like 8,300. This will keep getting up. My guess is ultimately we're 4,000 tons here, close to 10,000 tons of thrust. But this is kind of the next level, or the next version of
Yeah,
the
because
super heavy.
if it's bigger than it is now, then likely it'll be less thrust. If they keep the same thrust but increase the weight.
So the booster will look a little naked on the bottom because the Raptor 3 engines don't require a heat shield. So it looks like there's kind of parts missing, but that's just because the Raptor heat shield does not. The Raptor 3 does not need a heat shield. So it's just standing there in a bathed in flaming plasma. But it's a lot lighter. Yep. Integrated hot stage. I think it looks amazing. And the ship's a little.
There's that section.
A little longer, a little more capable. Moving to 1,550 tons of propellant capacity. And my guess is this probably ends up 20% more than this long term. And yeah, you can see the heat shield is sleeker, so much smoother boundaries. As the boundary of the heat shield going to the leeward side is very smooth. No more jagged tiles. I think it looks very sleek. And this version we still have 6 engines, but a future version will have 9.
Oh, wow.
But with the Raptor 3 again, we have improved.
Probably for like the fuel carrier, maybe needs more boost.
Reduced mass,
or lit.
higher specific impulse. This is the Starship version 3 is really the version that is, I think, achieves all of the key elements. I mean, generally with any new technology, it takes 3 major iterations of any new technology to have it really work well. And this with Raptor 3 and Starship and Booster version 3, it should be able to achieve all of the things that I just mentioned, which is a rapidly reusable, reliable rocket with orbital refilling. Basically, all of the ingredients necessary to make life multiplanetary will be achieved with version 3 of Starship, which we're aiming to launch for the first time at the end of this year.
Wow. Oh, here we go. It's so much taller,
Yeah, so
actually.
you can see this is
20 meters?
kind of where things are on the left,
Almost.
where things will be end of this year in the middle, and as I was saying, kind of where things will be probably long term.
So we have booster height that is much taller, ship height that is also good chunk taller. This is actually much bigger than it's crazy because the current one is so big, and the fact that the future one is even bigger.
Yeah.
Like, Jesus.
142 meters. So, but the one in the middle will be fully capable of doing Mars, and thereafter it'll be a lot of performance improvements, and as has been the case with Falcon 9, we always end up making the rocket longer and increasing payload. So that's the game plan. Pretty straightforward. But it's important to emphasize, even with the rocket that we'll be launching just at the end of this year,
very lackluster in
it will be
details.
capable of making life multiplanetary, and thereafter it's just about continuing to hone the efficiency and capability of the rocket, and reduce the cost per ton and reduce the cost per person to Mars, and like I said, ultimately make it so that anyone who wants to move to Mars and help build a new civilization can do so. So anyone out there, like, how cool would that be? And even if you don't want to do it, maybe that you have a son or daughter who wants to do that, or a friend who wants to do it. And I think it would be the best adventure that one could possibly do is
Like, he's acting like it's gonna be a vacation. Like, yeah, just go there, you know, like build a new society and like you're chilling. It's like, dude, it's a gonna be a borderline labor camp initially. You know, if depending on how long they even survive, if they even make it there, like, you know, like he's acting just like, yeah, like just go build a new society, but it's like it's gonna be hard work. And also there's a high chance that you won't even survive. So I don't know.
to go and help build a new civilization on a new planet.
I guess though, and also I feel like he's also lackluster in details because a lot of the in-between stuff that's happening now is very boring. It is just them launching, collecting data, reviewing it, making small iterations, doing that again, and that's just gonna have to keep happening. I more so just want to like understand the logistics of like the in-flight refueling, like how like specific. I guess we still have a little, like 10 minutes left, but you know, like the Mars base, like what are the initial steps, like what are the challenges you're talking about now? Like I want to kind of talk more about like the challenges that they're having a hard time getting over, or problems they're having a hard time solving, because I don't know, I feel like the hard problems are the interesting stuff. I haven't heard any of that yet.
So yeah, ultimately we'll have 42 engines, which it was inevitable. As the prophecy foretold by the great prophet Douglas Adams in his book, The Hitchhiker's Guide to the Galaxy, the answer to the meaning of life is 42. And so inevitably, the Starship stack will have 42 engines.
I was like, I don't get that reference. He really loves Hitchhiker's Guide Galaxy.
And in terms of payload to orbit, what's remarkable is that it's 200 tons of, Starship will have 200 tons payload to orbit with full reusability. So this is twice the capability of the Saturn V moon rocket. The Saturn V moon rocket was fully expendable. Starship is fully reusable, but will have twice the payload to orbit of the next biggest rocket that made it to orbit, which is the Saturn V. In fact, without reusability, Starship would have about 400 tons of payload to orbit.
Interesting.
So this is a very big rocket, is what I'm saying.
That's cool too, because I think if we do want much larger orbital structures too, eventually, just having an expendable rocket that someone's willing to pay for to get a giant ass thing into space if needed is just good too. So I think that's kind of cool that it's double 400. Like that's insane.
So, but you need a big rocket, to make life multiplanetary. And then along the way, we could do very cool things like have a moon base, like Moonbase Alpha. Like long ago, there was a TV show about Moonbase Alpha. You couldn't think about the physics of that too much because apparently, like the moon base was like drifting away from Earth. But anyway, we should have a Moonbase Alpha, which is the next step after the Apollo program would be to have a base on the moon. So you could have a gigantic
military installation,
science station.
It was like he was like the fact that he said science station instead of military. Like I don't know,
doing research about the nature of the universe on the moon would be very cool.
If you said military base, like that would like spur like international fucking outcry or something.
So in terms of like when can you go to Mars? So you can go to Mars every 2 years or every 26 months.
He talked about this on the last one. The 2025 Mars is like close to us, I'm pretty sure, but it takes like a lot. Depending on the year, it takes much longer for you to get to Mars because of the like orbit of it and its relation to Earth.
So the next Mars opportunity is at the end of next year in about 18 months. So November, December is the next Mars opportunity. So we'll try to make that opportunity if we get lucky. I think we'll probably have a 50-50 chance right now because we've got to figure out orbital refilling in order to have enough capability to go to Mars. But if we achieve orbital refilling in time, then we will launch the first uncrewed Starship to Mars at the end of next year. So,
like, I feel like he just brushes past orbital refueling when like that is the one of the biggest problems. I feel like that's yet to be unsolved.
So this gives you an illustration of how does a spaceship go from Earth to Mars. So you got
Interesting.
blue Earth there and red Mars. And I mean, the actual distance traveled on the Ark is close to like 1,000 times further than the Moon. So you can't just go straight to Mars. You have to create this elliptical orbit with Earth at one point and Mars at the other side, at the far end of the ellipse, and then time the
That's crazy.
where you are in that ellipse to intersect with Mars. And this is the orbital transfer, how you do orbital transfer from Earth to Mars. And if you look on your Starlink Wi-Fi router, you'll see this image, because the Starlink Wi-Fi is Starlink Internet is what's being used to pay for humanity getting to Mars. So I'd just like to thank everyone out there who's bought Starlink, because you're helping secure the future of civilization and helping make life multiplanetary,
It's an
and helping make
interesting
humanity a
framing.
space-faring civilization. Thank you.
Here we go.
So this is a tentative game plan here, where we're hoping to achieve, where we
5 landers in 2026. I know he said tentative, and he said it's like a 50-50 chance they even make it to the next one. But they put 5?
increase the cadence of flights to Mars dramatically with every launch window. So every roughly 2 years, we are dramatically increasing the number of ships that go to Mars, and ultimately try to get to 1,000 or 2,000 ships, per Mars rendezvous. So I mean, as a rough order of magnitude, this is just guesses, obviously, but we need to get about 1 million tons, is my guess, to the surface of Mars to make a civilization on Mars self-sustaining, and get to that critical point where if the resupply ships from Earth stop coming for any reason, Mars still succeeds. Mars can still grow. And so you can't be missing anything. You can't be missing even like the equivalent of vitamin C or anything. You've got to have everything you need for Mars to grow.
Mm-hmm.
That's
The
essential.
checklist must
So
be
my guess is
insane.
that's about 1 million tons, but it might be 10 million tons. I hope it's not 100 million tons. That'd be a lot. But we want to try to get to that point and secure the future of civilization as quickly as possible. So we're looking at different locations.
Interesting, they already have base
The
locations.
lead candidate right now is the Arcadia region. So
One
now
clap.
Mars has a lot of real estate, but when you combine all of the factors and say, okay, we can't be too close to the poles. We need to be near ice to get water, and can't be too mountainous for the rockets. Then it narrows down to a smaller region. So Arcadia is it's one of my daughter's name is Arcadia, actually, and is one of the options. So we got the
Tesla,
first starships on
Optimus,
Mars, gather critical
robot.
data. So the first flights there we'll send with the Optimus robot. So we can go out there and
If this robot's even working, let alone autonomous or whatever by then.
explore and kind of prepare the
This is cool though. The fact that we are sending actual humanoid robots now to a planet instead of like a rover I feel like that in general is a big step. That I didn't even think about that. Actually, like humanoid robot for space, like that's crazy. Actually,
the way for humans, and that'll be a
I've said
very
that's
cool
crazy
image
a
if
long
we're able to
times,
achieve it.
but this-
By launching end of next year. It would actually technically arrive in 2027, but that would be an epic picture to see Optimus walking around on the surface of Mars. And then with the launching 2 years later, we'd be sending humans, receiving the first missions are successful and they land successfully, we'd send humans on the next mission, and we really start building the infrastructure for Mars. So, anyway, maybe just to be safe, we might just do two landing episodes with the Optimus, and do the third one with humans. We'll see. So, that classic picture of the workers on the Empire
so
State.
Annoying. Wait, going back though, look at also okay, yeah, this thing alone looks crazy. This fucking like rover like tug carrier thing, like this looks crazy.
Optimus, and do the third one with humans. We'll see.
Wonder what these domes are down. Like you could see like pipes going into here. If there's a good channel called like I can't remember what it's called, like Anthrofuturism. But they made I butchered. I'm like cannot type right now. They made these videos about this is Anthrofuturism. About how to terraform other planets, and it's pretty accurate, and they kind of made like simulations. Super cool, like very interesting stuff. Would highly recommend watching, and it kind of like goes into the like actual logistics, like specifics of like why you have to do certain things down on the planet. This to me looks like something with like they're making like barriers around this, like with dirt, and then they're transferring stuff like this. So it could be a base, but it also could be some sort of like power generation. Like I can't tell what's coming out of here, but like why is it like a black dome like this? Like that is interesting.
So that classic picture of the workers on the Empire State.
Yeah, I saw this one coming down or taking off. I feel like there's also no talk about like the dust. Like if this thing was taking off or landing here, this entire place would just be fucking dust. And that would also in turn ruin like things like solar panels, like. And also that like the specifics like that are why like this is just like it's still hard for me to picture the timeline that they're talking about, because of like once you actually get there and start doing shit, like there's going to be so many other problems that arise that you're going to then need to fix, which is going to push back other problems that you have to solve or that are already scheduled to be solved, and like so forth. It's like typical tech debt in a way, with like dealing with like technology. I mean, that's also like, just bridging that into like other problem, or knowledge domains is like similar. I guess that's sometimes why it's hard for me to really believe the timeline. It's just like, what about like all this other stuff? But also that's probably why, like, that is a good like mentality, because getting bogged down in the details does slow things down.
And then for communications on
I
Mars,
answered my own question a bit, but yeah.
we'll be using a version of Starlink to provide internet on Mars. Yeah, so the speed of light.
3 minutes, that's pretty good. I think right now it's like 10 minutes to the moon with just like normal radio signals, like non, I don't know, Earth or Mars, I think it's, I don't know what it is now.
Moving at the speed of light, your best case scenario is, I guess, running around 3.5 minutes to Mars, and then worst case is 22 minutes or more, because Mars is on the other side of the sun from Earth.
I see. I didn't even think about it depending on the orbit again.
So anyway, it's good. It's quite challenging to do high bandwidth communications with Mars, but Starlink will achieve that. Yeah, and then we'll have the first humans lay the groundwork for permanent presence on the.
Yeah, okay. Mission objectives include surveying local resources, preparing landing services, i.e., labor. Like you're just like literally a body for labor when you're there initially. Setting up power generation, habitats, labor.
On the surface. And yeah, the goal, like I said, will be to make Mars self-sustaining as quickly as possible. So it's just a sort of rough idea of what things will be like for the first city on Mars. My guess is we'll probably put the launch pads a little further away, or the landing pads,
Yeah.
just in case. But I mean, for Mars, we're going to need a lot of solar power.
So let's see, 10 launches from Earth per day across several cities. Like, is that several sites? Like, that is 10 launches per day. 200 plus tons to low Earth orbit per launch. 1.5 million low Earth orbit per Mars transfer window. Yeah, and he in the past, Elon talked about having like a parking lot in space and having like 1,000 plus starships just sitting in orbit ready to take off when like the transfer window comes around. Which again, the logistics of that just seem crazy, but like per transfer, so that kind of goes into like this 1.5 million per transfer window, because that's about like, you know, almost 10 times 200. I mean, that's 2 million, but you get the point. Tons to low Earth orbit. Oh, I see. Tons to Mars. Oh, I see. I don't really get this, actually.
Will be, you know, since you can't really walk around on the surface of Mars, at least as yet, until Mars is terraformed to be like Earth. You need to walk around with a Mars suit and be, you know, initially in kind of like glass domes. But it would work, and eventually we can make Mars into an Earth-like planet.
Are we like forging the glass here? Like, what are the chances that pieces to a glass dome survives a rocket launch, just in general, let alone to Mars?
And we want to get to the point where we're transferring over,
I guess once we're in space, it's
1 million
freezing,
tons at every Mars transfer window. And then that's like a serious civilization. A megaton per transfer window.
but-
So, yeah, it have a lot of spaceports. I mean, because of the fact that you can't fly there continuously and you have to transfer in these windows, you'd have a gathering of 1,000 ships.
Yep, there
or
it is.
2,000 ships, or more than that. So we have this kind of like Battlestar Galactica feel, where all these ships are in orbit, waiting to depart, and then they'd all depart.
Sounds so cool.
I think an amazing image of all these ships departing at once. And then you're going to need, obviously, a lot of launch pads, a lot of landing pads on Mars. Or you'll need to move the ships off the landing pad pretty fast. So if you've got, I don't know, a few thousand ships inbound, probably need at least a few hundred pads, landing pads. And anyway, we'll solve that problem later.
That's like the motto of Elon Musk.
So, yeah. Anyway, this is like an incredible thing to have like this.
Here's my title payoff, by the way. My title's How to Build on YouTube's How to Build a City on Mars. A city on Mars. Establishing self-sufficient city on Mars will require upwards of 1 million people. Yeah.
Amazing city on Mars.
You have like a family
The
here, like
first
watching.
City on another planet, and a new world. And it's also an opportunity to, I think, for the Martians to rethink how they want civilization to be. So you can maybe rethink, like, what kind of form of government do you want? What new rules do you want to have? There's a lot of freedom and opportunity in Mars to do a recompile on civilization.
Implying that Elon Musk will have zero say in it.
Which will be up to the Martians.
Doubt. Maybe.
So, all right, let's get it done. Thank you, everyone.
All right. That was not as much info as I would have like thought or hoped for. It is, I can't help but get this idea or image out of my head where Like, one company owning everything, owning almost everything that you need to survive on another planet. I guess, you know, it's like SpaceX or Elon Musk will own the communications, they'll own the ride, the rocket, they'll likely be paying for the terraforming and the you know, bases on Mars, like all of that. They'll likely own all that entire like stack. You will be there doing hard labor for who knows how long to get the planet potentially to a more livable state. You will put there's a probably a high chance at least early humans going there will die. Like, I guess like it's cool in theory, but in reality it's going to be very rough and very hard. Living there is going to be, you know, like it's very hard. And I talked about previous astronauts even living in the International Space Station now. Like, mentally it's very tough. I don't think a lot of people have the mental fortitude to be able to survive something like this, like leaving everything, going to do labor on another planet with the high chance of, you know, dying and the unlikely chance of survival. You know, I think that's like kind of the reality. I'm very optimistic that we'll get there in a, you know, in some way. I would hope it's more equitable for the people like, you know, going there. But I don't know, I guess he kind of paints as like cool sci-fi sunshine and rainbows, but it's gonna be, initially it's gonna be very brutal. It's gonna be rough. So I'm hopeful that they'll get this. Also, his timeline is so aggressive again. Like, he said like 5 launches to Mars by next year. Like, doubt. Sorry. But cool. It's still cool otherwise. And then let's actually, I think on their website they had some more. It's like literally the comments are so cancer. It's like crypto bots. People like this guy's a bot. You know, it's like, who? Like, it's kind of crazy. Like, wow, great addition. 4 retweets, like, fucking bot. Alright, Mars and Beyond, the road to making humanity multiplanetary. Establishing a self-sufficient city on Mars will require upwards of 1 million people and millions of tons of cargo to be delivered to the Red Planet by launching more than 10 times per day to maximize transfer window that open up every approximately 26 months. Several thousand starships will ultimately transfer crew and equipment to building a lasting presence on another world. It's also crazy that they need 1 million people. Like 1 million people. That's crazy. Average distance of 140 million, sorry, not thousand, million miles. Mars is one of Earth's closest habitable neighbors. Mars is about half again as far as from the sun as Earth is. So still has decent sunlight. It is a little cold, but we can warm it up. Its atmosphere is primarily CO2, some nitrogen, argon, a few other trace elements, which means we can grow plants on Mars just by compressing the atmosphere. Okay. Again, sounds easier than said than done, likely. Gravity on Mars is about 38% that of Earth, so you'd be able to lift heavy things and bound around. That is cool. Furthermore, the day is remarkably close to that of Earth. It's like very close. The day, whoops, you can't see. It's like 24 hours, a little over. 6 months to get to Mars, 2 moons, 14 orbiting satellites. SpaceX's Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, represent a fully reusable transport system designed to carry both crew and cargo to Earth orbit, the Moon, and Mars and beyond. Starship's the world's most powerful launch vehicle ever developed and capable of carrying 150 metric tons, fully reusable, and 250 metric tons expendable. Every 26 months, the orbit aligns. So this is what we saw in that video. I really like this though because it's a very simple way of showing how to get there. Like, it's a great just visualization in general. Starship will enter Mars' atmosphere at 7.5 kilometers per second and decelerate aerodynamically. Vehicle's heat shields is designed to withstand multiple entries, but given that the vehicle is coming to Mars, atmosphere experience higher level of atomic oxygen. We expect to see harsher conditions during entry. The engineering video below shows actual Starship heat shield materials being tested in a simulated Mars atmosphere. Okay, we saw this on the video there. Mars 2026. SpaceX is planning to land the first Starship on Mars in 2026. These first vehicles will gather critical data on entry and landing, serving as the forerunners to future crew and cargo deliveries to the Martian surface. All right. The fact that they showed Tesla Optimus here is... I mean, like, Tesla is like... It's just barely walking. Or dancing, at least, I should say. It could dance, right? First humans on Mars. The first human explorers to visit Mars will lay the groundwork for permanent presence on the surface. The mission objectives will include surveying local resources, preparing landing services, setting up power generation, and building habitats. This is, quote, "You want to wake up in the morning and think the future is going to be great. And that's what's Jesus Christ. And that's what being a spacefaring civilization is all about. It's about believing in the future and thinking that the future will be better than the past. And I can't think of anything more exciting than going out there and being among the stars." Building a city. Key technologies are required to establish a permanent home on Mars and provide opportunities for those on Earth to take part in making life multiplanetary. New industries will be needed for fields including power generation. Hopefully, though, like, as we are getting solar, like, small modular reactors figure out, nuclear power is the solution for energy, and then also solar, but, like, RTGs exist, which is, like, a form of nuclear power for spacecraft in general. So, I mean, like, I imagine that would be the solution. I mean, the radiation problem is, like, radiation's a problem, but if you're going to space, like, you're already getting a fuck ton of radiation anyways. Resource mining. Yeah, the resource mining is this real thing. Propellant, yep, propellant production. That's where I was said earlier. I was like they need to talk about, like, actual fuel. Construction, communication, and transportation. It also looks like, looking at this more, it looks like this is, like, underground. Like, quite a good chunk, like, you know, reasonably deep. And then this looks like they're building one of these here. This dome looks like that the, like, Galactic Senate meeting dome from Star Wars. Establishing launching satellite landing sites will enable global mobility and return capabilities to Earth. Excuse me. Starship was designed from the beginning to run off liquid methane and oxygen, natural resources that can be mined and refined on Mars. All right. Well, that's it. That's it. All right. Well, now we just got to wait and see. There's really not much else we could do. Not much more we can do. Starshield? I've actually never seen this. Secured satellite network for government entities. I didn't realize it was a, like, specific product for that. inter-satellite laser communication terminal, which is the only communications laser operating skill orbit today, can be integrated into partners' satellites enable So you could like connect to the Starlink network in space, like satellite to satellite. So do they build satellites for people? It seemed like they didn't. This just seems like a Starlink. Anyways. All right. That was cool. Cool watch. Oops. If you want to watch it yourself, here's the link to it. Go crazy. Yeah. Guess just wait and see. So you said that the next Starship launch, though, later this year we'll have the larger system, the larger rocket. I wonder how much what the data is like for that. Like how does that change things? All right, then I have a few other smaller videos, just random ones that are pushed to me that we like to watch. Looks like this company Pixel's Firefly satellites, a new way of seeing Earth. Earth observation satellites are also a kind of a newer trend that have been taking off. And it looks like this is just another one of those brands. Looks like it's potentially they're based out of India. Built at Parallel HQ. Oh, this is just a designer. Or the website. Alright, let's watch this.
Earth is more than just our home. It's our most critical resource. But how well do we really see it? Every decision we make about food, water, industry...
I guess, I want to know how these guys are different than, Maxar or Planet or whatever. I think it's, they own, Planet.com? Yeah, this company. They own Planet.com. These guys are kind of, more, on the, I don't want to say on the forefront, but I've seen them, their images used a lot more. Them and Maxar. I think it's 2 X's. 1X. Maxar I think is more of a legacy. I would almost consider them part of the military industrial complex. Yeah, 2 companies. Okay, great. Anyways, so it seems like these there's definitely quite a few of these guys popping up now.
Depends on understanding our planet. And for too long, we've been seeing only part of the picture. Satellite data has shaped the way we monitor Earth, but conventional imaging has its limits. It shows us the surface, but not the details that matter the most.
We already have this. This exists.
The ones that tell us what's changing and why. That's why we built the Fireflies. A constellation of hyperspectral satellites designed to see beyond the visible, to bring clarity where there was uncertainty.
Also, is this standard? Oops. It looks like the entire body and everything is just solar panels.
On the visible, to bring clarity where there was uncertainty.
Also, look at this deployment thing. How are they deploying these?
To decode our planet, layer by layer, pixel by pixel. With 135 hyperspectral bands, Firefly captures data at an unprecedented level of detail. Its 5-meter spatial resolution ensures clarity at scale, while a 40-kilometer swath width enables wide area monitoring without missing
lingo used in this video is
And with a 24-hour revisit frequency, the Fireflies deliver real-time intelligence, keeping up with the rapid changes. It's not just about seeing, it's about knowing. Knowing where our food supply is at risk before yields start dropping. Knowing when pollution is spreading before it reaches our cities.
Okay, no offense, but like knowing is like the easiest thing. It's more so like what can we do with it? It's like, okay, great. What are like now what are we gonna do with this? Like before it reaches our cities, like what are we gonna build a fucking like pollution wall? Like I don't know. Because it's just like warning.
Knowing how to act before the damage is done. And when this knowledge is accessible, the way we respond to global challenges changes forever. The Firefly constellation isn't just about imaging Earth. It's about understanding it, deeply, completely, and in time to make a difference.
Firefly separation confirmed.
Alright. I mean, that was an ad, but get the idea. Okay, interesting. I don't know. Not quite sure still how they stand out from the competition, but cool to have more competition nonetheless. Building a health monitor for your planet, for planet Earth by manufacturing and operating a constellation of cutting-edge hyperspectral satellites. Interesting. Interesting. Alright, then I found this cool video. Not just this plane looks cool, but not exactly sure what they do. Could just, it looks like a restoration. The Volar Lightning. Is this the vehicle, bro? This looks like the when I think like retrofuturism, like this airplane is like exactly what comes to mind. Okay, that did not help. All right, let's watch this.
Well, the history of this aircraft and how I came by it are
This
they're
thing looks
interwoven
so
into
cool.
my whole life. And my great uncle was growing up in the shadow of World War II. He absolutely was in love with the P-38. It was the epitome, I think, to him of what is beautiful in aviation. And he wasn't able to be a pilot with the Air Force because he was colorblind. He wound up going into engineering. He later discovered that he could be a private pilot, and he went on to get his instrument rating, and then he wanted to build a plane. And his friends told him he should build a Vans. And he's like, nope, build a Stream. Jim he's not normal, you know, in a lot of ways. He's really special. To be that smart, but also an artist and a craftsman the way he was.
I'll go. You can do yours too. That's cool. The open looks neat. Again, not what I thought this was, but cool nonetheless. All right, that's really all I had to do for space stuff today. That's also really all I had planned. I'm honestly super tired today. We can watch. We'll watch this a different day or something, but have this up here just in case. But yeah, that's all we're gonna do today. Just a chill Monday. There's also very light on news today. There hasn't been much, so that's also kind of why. Tomorrow we'll be back at it. I'm just looking at any headlines. I don't know. It's all kind of just like low. Nothing big impact today. This Friday though, we have Summer Games Fest. I might stream it. We'll see. But regardless, we're going to be watching all the stuff that comes from it. And we also have there's one other thing happening this week. Can't think of it. It may be next week. I think Circle's IPOing this week. No, yeah, Summer Games Fest Friday. WWDC, that's next week though, actually. That's what I was thinking of. That's next week. Alright. Anyways, yeah, we'll be back tomorrow with some more news. Hope everyone had a chill Monday and had a good weekend. And I don't know, I guess I didn't learn too much from Elon Musk's from his talk that we watched. Not anything crazy new, so oh well. Alright, we'll be back. I'll be back tomorrow, 9 a.m. Pacific, for some news. We'll cover actual news tomorrow. So appreciate everyone showing up and hanging out. And I will see you later.